Since we released the tenting kit for the Dygma Race, we've been constantly surprised by its success. They've been selling like hotcakes, and your feedback has been great. We've sold out all 4 batches we've made since June 2021, and we're making the 5th one as we speak. So when it came to designing the Dygma Defy, we knew it had to include a tenting solution right off the bat. One that would not only live to the expectations set by the race, but surpass them. And boy, were we set for a challenge. Hi Dygmates, I'm Dominique, and in today's video we're going to take a closer look at one of the most amazing parts of the Defy, the built-in tenting and reverse tilting solution. The Dygma Race tenting kit has been praised for its build quality, sturdiness, and stability even at high degrees, but it's not perfect. Its main issue is that because it's an attachment that was developed afterwards, we didn't foresee that putting a tenting kit would add 1 centimeter to the height of the keyboard. The tenting kit consists of a big steel plate with metallic legs. That makes it resistant, but also heavy. Those 2 flaws could be solved by integrating the tenting legs into the body of the keyboard. But us being us, we wanted to add a couple of cherries on top. The first cherry would be having higher angles to choose from. 40 degrees is pretty steep, but some users prefer more, and having more angles in between would be great too. The second cherry would be to include reverse tilting. That's very useful if you want to keep a neutral angle for your wrists, especially when typing on a standing desk. However, these changes and improvements presented a few challenges. Modifying the base to introduce the legs completely disrupted the underglow system. The tenting legs sat right in the middle of the light pipes, forcing us to completely redesign the underglow solution. This is easier said than done. It took us dozens of iterations and testing to get the underglow right. Check out this other video to see that story. And now we had to create something completely different. But let's say we found a workaround for the underglow. We would still have a major space problem. Besides the tenting solution, the base also had to fit the batteries, the neuron, the electronics, etc. It's like playing Tetris, but all the pieces are those pesky S-shaped ones. On top of that, making the reverse tilting work seamlessly requires a lot of precision. Plus, we also wanted people to find it intuitive and easy to set. And finally, we must do all of that without losing the praised sturdiness. With these must-have features in mind and being aware of the dangers ahead, the team started to create the first prototypes. First hypothesis, the clamp. These first iterations were based on a simple hypothesis, having a leg that slides through a rail with a clamp mechanism to lock it in place. The idea behind this approach is that this simple mechanical solution would allow for many angles between the lowest and highest position. We tried different designs for the clamp to find the best user experience, including a very cool eccentric lever. But in the end, all the prototypes presented similar issues.
Basically, we had 3 different issues. The main one was the mechanism didn't allow a very wide range of angles. The other main issue was the strength on low angles. If this rod is not normal to this surface or perpendicular to the leg, it's not strong. Like for example, like this, you can just block it and it's very easy to move. But if you have a very perpendicular, it's super strong. Another kind of issue we have with this solution is that both legs have like infinite positions. So it's very difficult to choose the right position for the front leg and for the back leg. And if you don't choose exactly the right angle, you will have wobbling on the keyboard.
Second hypothesis, the sliding rod. Okay, we had established that the sliding mechanism held by pressure wasn't working. But what if the solution was in the opposite direction? A sliding rod on the legs that would clamp to fixed positions on the base. The first prototype was a wedge that slid through the legs and fixed its position with a screw on the top. Manel explains it better.
Okay, this solution, it's based on a fixed length leg that you can move with a slider on the leg. The first advantage, or the main advantage, is that it's very resistant. Basically you can lock it, and it's quite strong. It has a very big problem in our opinion, and we discarded that because you need a tool. It affected a lot to the UX. You need to put the right position and then fix it with a tool, and we didn't like that.
To top it all, you could set the wedge to any position on the legs. So we still had the wobbling problem when both wedges weren't adjusted exactly right. So what if we had fixed positions on the leg instead of the base?
This new concept, it's like way more cooler. In this case, we have a slider and we move it along the leg, and we have different steps on the leg. So we can choose easily the angle. To block it, we have a clamp, and it's quite strong, and we also can fold it. The main problem here is that the high angles are not strong enough.
To solve this problem, we tried substituting the wedge with fixed positions on the base. So now the rod can be inserted into the different positions, increasing the stability.
As in this concept, we had the limitation of the high angles. Then we decided to change a little the concept, and instead of having angle positions here in the leg, we put the angle position on the base. Doing it like that, the angle position is also a blocker. So it's a physical piece of plastic that blocks the rod and keeps it in place. So with this solution, we had like a smaller range of angles, but all of them were stronger. So the concept was good, but not good enough.
Okay, so one rod wasn't cutting it, and it was driving us crazy. Nothing we tried was working. So if something isn't working, what do? Well, go all in, of course. What if instead of one rod, we used two? A shorter one for the lower angles and a longer rod for the steeper ones. Manel?
Okay, so this is the next concept. And here we have a very big improvement on the stability. This is much more stable because we have different positions, and it's very easy just to select. Well, it's not easy, it's not the word, but it's possible to select the same angle for the front and for the back leg. And that's an improvement. And we can reach 45 degrees, more or less. That is fine, it's better than the previous concept. And at the same time, it's possible to have total stability because you have different marks, and you can exactly match the angle of the front leg and the angle of the back leg. So it works fine. The main issue here is the UX. Basically, it's very difficult. You have a lot of marks for one leg, a lot of other marks for the other leg, on the front, on the back, and choosing the angle is like a nightmare.
At this point, we had completely run out of ideas. We were stuck. However, it was a working solution that met most of our criteria. It could be folded into the body, it was stable, and offered multiple angles. So, although we didn't love it, we decided to settle with it and give us some mental space. We focused our efforts on polishing the reverse tilting, which, quoting Manel, was a pain in the Although the reverse tilting had been clear for some time, you can see two small legs for two reverse tilting angles in early prototypes. We soon realized that it only worked if it was placed in a very precise spot on the base. What was the solution? Printing more than 50 different bases to find that sweet, sweet spot. And you would think that was it, right? Wrong.
Since the beginning, we agreed on having two reverse tilting angles, a short one and a long one. So we have two special legs just for this, okay? The short leg and the big leg. The thing here is that you need to have like an angle on the front leg tenting to match the angle of the reverse tilting. Basically, it's an added complication because it's not only matching the front leg with the back leg, you also have to match with the reverse tilting leg. And it's a bit more complicated, but it's like adding much more functionalities to the product, so it's cool.
Luckily, after printing and testing innumerable angle selectors, we got it right, only to have to redo it all again. Third hypothesis, no sliding. At this point, we had a whole tenting system that had almost everything we wanted. It only had two drawbacks. It could only go up to 45 degrees, and the user experience wasn't the most intuitive. We had to accept that because we had to move on to other parts of the keyboard, but we weren't happy, especially Manel. Fortunately, even though we told the engineers not to think about the tenting kit, they did.
So this is like our final solution. And we were like turning crazy with all the different ideas during months and months, and finally we had a good solution. Actually, we were really close to work with the last solution, but we were not happy. It had like a small limitation, especially the number of angles and also the UX. And then we started thinking, and maybe we can have two different rods, one rod for the high angles, another rod for the low angles. And this is the angle selector, and we use the angle selector, one part of the angle selector with one rod, and then we can use the other rod for the high angles. And this is like the solution we finally chose, and we are very happy that we insisted on that because we think it's much better than the previous ones.
Suddenly, thanks to this idea and all the learnings from the previous iterations, all our problems seemed to just go away. Well, it wasn't immediate. We had to print hundreds of legs and rods, and also tested them in a gazillion positions until we found the perfect combination, because it had to work with the reverse tilting too, remember? But once that was solved, we cracked it. The new system gave the rod a very good angle for force distribution, making the kit very stable in any angle, allowing us to reach steeper positions, from 0 degrees up to the desired 60 degrees with another 7 different positions in between. Plus, the user experience was much more intuitive. With all that, plus the reverse tilting, we checked all the boxes. A tenting that had no extra height at 0 degrees, more angle options to choose from, including higher tenting angles, a solution that is extremely sturdy and durable, a very intuitive user experience, and on top of that, the design is sleek and defiant. We have to give a big shout out to Manel and all the design team for such a huge accomplishment. Nevertheless, there's still much work to do. This was the road until we found the ideal solution. Now we need to prepare the design to manufacture it, which we've been doing for the last months. But that's a story for another day. And talking about stories, which do you prefer we talk about next? How we came up with our ludicrous 8-key thumb clusters? Or how we found the new solution for the ultra bright RGBW underglow to create the necessary space for the tending solution, the batteries, and the electronics? Let us know in the comment section below. And of course, don't forget to like and subscribe so you don't miss our next videos. Until then, I hope you've been having an awesome summer, and I'll see you in the next video. Bye!